Hey everybody, so I want to do another problem from the homework, see if we can get a good idea of how to do some of these more tricky conditional probabilities, especially these ones that require a tree. So I really like this one, kind of talks about blood alcohol content and road deaths. Road deaths are one of these things that we rarely talk about, motor killings. We normally call them accidents, although normally we wouldn't consider it an accident if someone has been drinking and driving. So more appropriately, I normally try to refer to them as motor killings or something along that line. So we see here that there's a crash with a fatality, and we have different probabilities. So the given here on each of these is that there was a crash with the fatality, and then we have a different range for the blood alcohol content of each of the people. Suppose, so then I'm jumping down, I'm not going to read all those numbers. Suppose over a certain stretch of highway during a 1 year probability, the 1 year period, the probability of being involved in a crash with at least one fatality is 2.7%. It has been estimated that that 15% of all drivers drive while their BAC is greater than 0.9. Determine the probability of a crash with at least one fatality if the driver is legally intoxicated, greater than 0.09. I actually think our standard in Oklahoma is 0.08 for legally intoxicated, but we're going to go with what the problem says here, okay? So first thing we're going to do here is we're going to try to set up a tree. I've got Excel open. Excel is not the greatest way to make a tree, right? But essentially, we're going to make like a little node here. I just put a 0. And we're going to have like a going up and going down. All right, I know this is cheesy, guys, but I'm trying my best here. Actually, I don't see how to do that on the keyboard. Oh, there it is, that one. So it's like I went down, right? Okay, so so what do we want to do here? We want to have, my conditionals are all about crashes, right? So I need a crash. Crash with fatality. Which means up here, I'm going to have opposite of that. So no crash. With fatality. You can still have a crash, actually, and a no crash. Just can't have a fatality. So the probability of a crash with at least one fatality, they told me it was 0.027%, which means this one has to be 1 minus that value. So I'm using Excel to compute that, 97.3%. Okay, cool. So then what we want to do is we want to break this down some more, right? So we want to break it down into, let me do my little arrows again. We want to go up. Actually, oops, cancel. We can leave that there, right? So let's come out here. Let's come out a little further, right? So we're going up and we're going down. I'm trying to make a tree. It's not the best I've ever done. Okay, so here we are with a crash with a fatality. So the next thing I'm going to do, I know I have a crash with a fatality. That's my given, right? So we're going to ask, we know that we have a crash with a fatality. We want to ask what's the probability that the driver was intoxicated, right? So we're considering a blood alcohol of greater than 0.09 as intoxicated, right? So this is intoxicated given, and I'm going to use that big bar there. I didn't spell intoxicated right, but given that we have the crash. So we know this fatality, that's the one that's given to us right here. It's 0.054. That's intoxicated given that there was a crash. Remember, we're out on this thing right here. That means we know there was a crash. So up here we're going to have not intoxicated. And that has to be 1 minus this probability of this given. So that happens 94% of the time of a crash with a fatality. Sorry, again, this one is not intoxicated, given that there was a crash. That has to add to 1, and I'm not considering anybody with a BAC between 0.01 and 0.09. They're all falling in this not intoxicated part. Okay, so then what I want to ask is, what's the probability of a crash with a fatality and the driver being intoxicated? So now I'm going to come out here to the end of my tree, and I'm going to ask, we want a crash and we want intoxication. So to do that, we simply multiply the branches that got us out there. So it's going to be less than 1% that gets us there. And let's do this one up here. This one is not intox and a crash with a fatality. So that will equal this number times this number. And then the other percentage, there'll be no crash, would be up here, right? So, okay, so those are my ands, those are my intersections. We want to know now, determine the probability of a crash with at least one fatality if the driver drives while legally intoxicated. So I think this question is asking the opposite thing. I think this one is saying, what's the probability of a crash given intoxication? So to do that, the easiest way, so this is a given statement, right? The easiest way is to do the crash and intoxication, and to divide that, by the given, the probability of the given, the intoxication. Okay, so threw up an error there. It's because I wrote that equal sign. I'm not allowed to put an equal sign there. So to do this crash given intoxication, we do the crash and intoxication divided by the intoxication. Okay, so I think we have all the pieces that we need here. This one was the crash and intoxication. And then I need to divide by the probability of intoxication. Well, that was actually given to me in the story. It's been estimated that 15% of all drivers drive while their BAC is greater than 0.9. So I can just put in here that 15% of all drivers are intoxicated. And this will give me this conditional probability that I know that the person's intoxicated. What's the probability that they cause a crash? So let's see if we got it here. I'm hitting submit. And I got it. And I got a little achievement icon there too. Okay, so let's go through that one more time, right? I did this tree to figure out what the probability of crash and intoxication was. I followed the tree because one of the things that was given to me was a conditional probability. Once I got to that condition, I can use the conditional probabilities. To get to the and, we multiply the branches of the tree. To do the opposite conditional probability, where the two probabilities have been switched, right? This one was intoxicated given crash. This one is crash given intoxication. We use this and we divide by the probability of the given. And the probability of the given was actually given here in this story. All right, so there you go. That is how you do this problem. Be careful. These ones with trees get tricky. You guys can do it. Keep working hard.